So today we're actually looking at graphs, and we're going to look at the difference between k over x and k over x squared. They look very similar, and I would say they're related in a lot of ways in how they look. So first of all, the graph of y equals k over x. This graph of every function with the equation of this form, where k is not 0, is called a hyperbola. And if you have a tough time spelling, you can maybe remember as hyperbola, kind of like parabola for parabola. That's how I remember it. Okay. And it says, what is the domain and range of the function? So one of the things you guys need to know is what it looks like. And if you look down the page here, right here is an example of k over x. So just looking at that, what is your domain and range? First of all, what's the domain? What are your possible values of x? All values except 0, exactly. So I'm going to write that just like we did on our homework earlier today. X such that x is not 0, right? And x is a real number. Now let's look at the range. We're looking at y values. Actually, it even tells us down below here. Notice that the sides of these never touch the axes. Okay? They get closer and closer and closer, but they never touch. What is that called, those axes that never get touched? Do you guys remember? Okay. We're going to talk about that in just a minute. So, the family of graphs of y equals k over x share another property. Each hyperbola in this family consists of two separate parts called branches. When k is greater than 0, the branches lie in which quadrants? Look at these two quadrants. Which one are they in? 1 and 3. In Roman numeral there. And if it's less than 0, which two quadrants is it in? 2 and 4. All right. So here's what happens. These graphs have a vertical. Notice it never touches, like I said, and you can think of it as a little imaginary dotted line going up and down along the axis. They're called asymptote. And it's 1s, not 2. Okay. And a horizontal asymptote also at 0. Yep. So you also have one going across this way. All right. Pause for me. All right. So on our notes it says graph y equals 24 over x squared. So I'm going to do that right now. Hit enter. There you have it. Okay. So you should write that down in the first block of notes on there if you've printed them out. Otherwise, somewhere on your sheet. Okay. And it said do that with a window width of x less than 5, greater than 5, or y less than 10, greater than 10. This is set up to be 10 and it looks like 8. 10 by 8. Yep, just sketch it. Okay. And the next one says graph y equals negative 24 x squared. Okay. I'm going to do, it said to clear it and to do it on another graph, but I want to do it on the same one so you guys can see the difference. So this one's going to be negative 24 over x squared. What do you guys notice? Yeah, they're just inverted, right? Okay, so one's going upward, just like with the parabola. When it's positive, it's going up, and when it's negative, it's going down. Okay, so the same with some number over x squared will be the same way. Also, think about the difference between that and a k over x. What do you notice? So if you look over k over x, notice where the hyperbola are right here. They're kind of diagonal from each other. And then if you notice the other one, we're looking at the cast, they're right next to each other. Okay? So you need to remember that if it's x squared, they're going to be on the same half of the graph. If it's just over x, they're going to be diagonal from each other. So it's just something you need to remember. Possible quiz question. Okay, if I show you a graph, can you tell me which one it is? Right? Okay, example. Also, tell me about the symmetry of this graph. Where are they symmetrical? So it's just one of the axes. Which one? The y-axis. So if I were to cut down the middle of the y-axis, it would be a mirror image of itself, right? It's kind of confusing right now because I have two of them listed. If I were to delete this, it's not going to let me. Oh, here we go. I'm going to shut the eye on that one, so we're only looking at one. There we are. Notice that we're only looking at this one. So if I were to cut down the middle of this, it would be the mirror image of itself, right? All right, the next one says for us to do the same kind of thing, but we are looking at 36x squared. So I'm going to graph this one actually on the same one because this one is a little bit higher of a number. Oopsie. What do you notice about this graph compared to the red one? Well, the lines are thicker there. Now, what do you think? It's a little bit wider. I would say it's probably steeper. If we were to go zoom out on it, we probably would notice that it's a little bit steeper, going up faster, okay, or horizontaling out faster. But it also seems to be a little bit further away from the origin here. Okay. So on this one, describe the symmetry of the graphs. Yeah.
How do you figure out the parabola if you don't have an x value?
If you don't have an x value?
Yeah.
Well, you can put in like several x values and find out what the y value is. You can make a table. Okay. So notice that this one's still the y equals 0 or x equals 0. The horizontal, the y-axis is the line of symmetry again. Okay. How about my asymptotes? Where are my asymptotes on this? Are the asymptotes any different than the other one? What's happening to this as it's getting closer and closer? It doesn't ever reach the 0, right? So x and y equal to 0 are both asymptotes again, okay? Same as the other one. Okay, last question on the bottom of the page. Notice that the graphs y equals k over x and y equals k over x squared have the same vertical and horizontal, like I just said, asymptotes. Okay? Asymptotes. So look, here's this is my k over x right here. All right? And this one is my k over x squared. So if I had drawn this correctly, my pencil got away from me. The asymptotes are the vertical axes because it's approaching it but never touching. And also the horizontal axis because it's approaching and never touching. Same with this one. Okay?